All right, moving ahead then in time to the 16th century. No progress in all that time. Still geocentric model. Went through the Dark Ages, and we're getting ready for the Renaissance now. And this Polish astronomer, Copernicus, what he did was he was still messing around with this idea, and he took Ptolemy's model and switched places between the Earth and the Sun. So in other words, he said, well, let's just try putting the Sun at the center and put the Earth where the Sun is. And so you can see on the data projector how this would look. Here you'd have Jupiter doing its epicyclic motion. You'd have the Sun wasn't doing epicyclic motion, so the Sun was just in a pure circle around the Earth. And then Venus and Mercury had a little different appearances because they were closer to the Sun. So really this retrograde motion is more viable for planets that are farther away from the Sun than the Earth, like Mars, Jupiter, Saturn, which were the only ones that were visible at that time. So what Copernicus did then is he just put the Sun where the Earth is and the Earth where the Sun is. And guess what he found? He found that he was still able to predict retrograde motion. So everybody goes, oh, hey, wait a minute. We had a mathematical model that gave us the right answer. Now I've got two different mathematical models that are giving us the same answer. So this is yet another thing that we can discover that helps us in the future, is different mathematical models can give the same result. This was unknown until that time. And it still doesn't make sense that it would be true even today. Different mathematical models can give the same result. That's very strange. And so people started saying, well, wait a minute then, what if neither one of them are right? And go, well, maybe there's subtle differences between the models that could be determined. But this definitely opens up the possibility of a heliocentric model. Now, I should mention here that Copernicus waited to publish his results on retrograde motion until he knew that he was dying. Okay, because he was afraid that he was going to be punished severely by the church and probably tortured, forced to recant his beliefs and even possibly killed. Some of Copernicus's followers were executed because they followed along with what he was saying. That was considered a direct threat to the church. But this opened up the door to a whole nother way of looking at the solar system. And the possibility, at least, that the heliocentric model, the sun-centered model, could be the correct one. Okay? And so, but we should mention here, and Copernicus is often credited with giving us the correct sun-centered model. This still isn't right. It's still not right. He got us on the right track. But he was correct in that it was a heliocentric model. And considering all of the threats that were posed from the outside for taking such beliefs, it was a very courageous stand to take. But what was realized is that to get the true model, it might need better measurements. Of planet positions. so that we can tell the slight differences between these models. And so at the time, these were non-telescopic measurements that were being made, but more in terms of angles. It's more like a fancy protractor. Or if you're into navigational tools on a ship, this would be like a large sextant. Something that could help you determine the position of a planet relative to the other zodiac constellations. And so along comes this guy named Brahe, and he's got the support of the king and is given all of the facilities that he needs to make observations and to make this new type of measuring instrument. So Brahe then develops tools to measure planet positions. And uses them on the planet Mars. Why Mars? Well, it turns out that in analyzing the retrograde motion of the planets, the Martian results were the least accurate. In terms of predicting retrograde motion. With the idea of epicycles. And so what Brahe then was trying to do was to probe the model at its weakest point and see if he could come up with the correct laws of planetary motion, because the Mars results just weren't quite what they should be. And it turns out the reason why the Martian results aren't as good as they should be is that Mars has a more elongated or elliptical orbit. And so that threw things off because Ptolemy's models had circles moving inside of circles. And so the farther you get from a circular orbit, the less accurate it's going to be. Of course, he didn't know that at the time. And so Brahe then is collecting all this data on the planet Mars that Brahe wasn't a mathematician. And so Brahe hired Kepler to analyze his Mars data. Kepler was a good mathematician. But then, once you do something like that, he hired Kepler, then he started realizing that, well, hey, wait a minute. If Kepler finds the correct laws of planetary motion, then he's going to get all the credit and I'm going to be forgotten. And that, in fact, is exactly what happened. Brahe, who's ever heard of Brahe? But Kepler, a lot of people have heard of him. He's got the laws of planetary motion on his resume and is well remembered. But Brahe, realizing that that could be a problem, he was kind of an eccentric guy too. His nose was cut off in a duel. He had a gold nose put on in its place. And he had his own cosmology. He believed that the planets were spheres, glass spheres that were filled with whiskey. And so there wasn't a whole lot of scientific support for his theories. But he still was able to collect good data. So anyway, he wasn't really giving Kepler enough information for Kepler to do anything with. He'd hired him, but he'd give him a couple of pieces of information about where Mars was, and not enough for him to really do anything with. And so Kepler's getting really frustrated, was probably thinking about quitting. And then one fateful night, Brahe went to a party that was thrown by the king. And Brahe was prone to overindulgence, drinking way too much. And so the king started speaking. And Brahe really had to go to the bathroom pretty badly. But it was considered extremely bad etiquette to leave the room when the king was speaking. And of course, the king was funding all of his expensive astronomical projects as well. But the king, unfortunately for Brahe, was in a very talkative mood that evening and went on for like an hour and a half. And in that time, Brahe's bladder ruptured and he died. And so that's a true story. His bladder ruptured. On his deathbed, Brahe said to Kepler, here's my data, give my life some meaning, find the laws of planetary motion. Even Brahe's family didn't want Kepler to have the notes, but Kepler got them anyway. So the result then is the correct laws of planetary motion.